Hello everybody. Well, welcome to this week's video. And of course, in the tradition of what we've been doing this month, we've already made a hammer, we've learned to make a drift, and we've even done an axe on a live broadcast. Well, today, what we're going to be doing is we're actually going to be making an axe of a different flavor. We're going to be making a tomahawk head or an axe head using what is called the folded method. Now, today, I'm going to be using this guy right here. Now, if you don't have any of these, all you got to do is find a farrier and he'll give you a buttload of them. They are farrier's rasp. They are very coarse, but what happens is just as soon as it dulls out, it's really no good to the farrier, so he usually has a pile of these things he has to throw away. However, this guy is really, really good steel. So if you play your cards right and you come in a couple of these, you can make a fantastic tomahawk out of these guys right here. The only trick is making what they call the bow tie, and we're going to have to cut this guy off, do a little bit of hammering, and then fold this axe around. And of course, that is the major difference in this type of axe. Most axes today, well, almost all of them exclusively, are made using the drift method. Basically, you have a solid piece of steel, it's slit, the drift is driven all the way through, and then opens up into the head where you put the handle. Not so with folded axes. What happens is this axe will be made into almost a bow tie shape. It will then be folded around and the two ends forge welded together. Now back in the old days, this allowed you to take a sheet or a bar of iron and make something as opposed to having to make a large block, or vice versa. So what we're going to do is we're going to get the fire going. We're going to have to cut this off, have to trim it a little bit, and then we're going to get started into making the folded axe. Okay everyone, the first thing that we're going to start off doing here is actually taking this piece and we're going to cut about a 7-inch piece off of this guy. So I'm right in here. Let's see what we got here. Got one main groove, actually got off a little bit on that other one. We're good. Once we get this bad boy cut off, and like I said, I'm doing this with kid gloves. As you can see, we've got our main cut right there, and then we can simply go over the other side and knock it off. Now we have our piece that we're going to use as our tomahawk head. Now the first thing we want to do is we want to take this guy, we want to hammer a belly into this guy, basically meaning that you're not going to touch the ends, but you're going to make a big swoop here along the middle. Laying it up here, starting in the middle, and working your way out. You're making a half pipe, like for skaters. So let's take another heat, and let's start working on it. Now a lot of this work is going to be an exercise in patience. So as you get here, you just start right in the middle. Make sure you don't let the sides crease or lap over. And don't worry about grinding off all the filing either. I've heard a lot of folks say that in order to use a piece of file steel as a knife, that you have to grind all the teeth off because it causes it to break or crack where the teeth are. That's BS. I'm just going to flat out say that. You can forge this guy and there ain't going to be any problem with it. So just keep at it. You can see we've got our first heat. We're going to keep working all the way down until I make this guy probably right at 1 inch, because that's going to be the strap that goes around the handle of the tomahawk. So you want that walled out. Now one of the things I got to tell you about working this piece of steel is remember that it is high carbon. Whenever you're working high carbon, and of course we're going to be forge welding it as well, you have to be very careful in the simple sense that the high carbon steel will burn much faster than the mild steel will. So you don't want to go up to the high temperatures that you would be if you're going to hard weld mild steel, but we'll get into that in just a minute. Be patient as you work this thing down, keep those edges from rolling over, and continue to work it out in that half pipe situation. We got a really good heat this time. And here we go, working that into a bow tie shape. Now, this piece may handle a little funky as far as the way it deforms as you're hammering on it because of the very deep groove teeth in one side. It may have a tendency to buckle in a way you're not used to. It's all right. Just work with it. As you can see, the shape is now coming out. Keep working it down. Now, as you can see, I'm having a bit of a tough time hanging on to this with just a regular pair of flat jaws. The ideal tool for this guy is going to be a pair of box jaw tongs, which are going to look like this. See that guy right there? It's basically a modified pair of flat jaws, but it will not allow this piece to twist or work away. So as we're getting into a little more education about different tongs, this is the ideal set of tongs for this piece of metal. And notice that they fit it exactly. That's not by chance. These are the tongs that I normally use to do these tomahawk heads with. Here we go. You can see that little bow tie shape that's coming out in it. Now, depending on how exactly big you want the haft of this guy to be, depends on really how long you want to pull this guy out. So I'm probably going to take another heat, maybe two more, and go ahead and pull this out and flatten it out before we actually get ready to do our forge weld. Alrighty. Okay, this guy still looks a little rough. We're good to go. Now, while it's still warm, you want to go to the center of the piece, right here, and start bending it over, just like this. See that piece right there? That's what you're starting to look for. Now, there's going to be a little bit of a trick. There is another pair of tongs I don't think I have shown you guys how to do, but they're called hook tongs. They look like this, and they're normally used for making S hooks, but they are ideal for this situation when you can grab the edge here and do so pretty darn securely. What's going to happen now is I'm going to take yet another heat. I'm going to bring this on down to these two sides are flush together. But the first thing I'm going to do is I'm going to go ahead and flux the inside of this guy right here. So let me do that now while I've still got some heat on here. This is not really proper fluxing heat, but we will get by. Besides, this isn't the big flux anyway. We're just doing this just so it can start cooking and removing some of that scale. You see it bubbling and sizzling. We'll put this back into the fire, once again holding it from the back side, and bring these two sides together. Now you are starting to get into a little bit more of a monkey when it comes to forge welding, because when you're forge welding high carbon steel, it's much more sensitive to the forge weld than something like mild steel. And that's really important because if you burn the high carbon steel, you absolutely ruin it for the edge that you're trying to get out of it. So treat this with kid gloves, especially for those of you that are working with coal. You know, coal is much more powerful than charcoal in a concentrated form. You will burn something up in a coal forge much faster than you will in a charcoal forge, just by the nature of how it burns. So, you want to be very careful with what you're doing. You do not want to overheat this. So even if you have to take 3 or 4 more attempts with it to get it right, that's okay. Work your way up. Don't get greedy with this particular project. This is training wheels, so take it easy. Get her set in the tongs. I've got a decent grip on her. Let's go to the anvil. Now, one of the real important things is trying to get this thing even. You want these two faces to be as even with each other as possible. And that's pretty important. And this thing is proving not to be the pair of tongs that I really want for this guy. So we're going to swap over and improvise. I don't do a lot of these, but you can make do. Now you can see how those pieces are put together. And that's not the best job in the world for right now, but it does not have to be. Because once we forge weld this, we can grind a lot of it off and bring it back into the right way we want to do it. Now at this point, what I want to do is I want to take this back into the fire and bring it up to a bright orange heat. Once I have brought up to that bright orange heat, I'm going to flux it and then go back in for the forge weld. Now remember, be cautious, be timid when you're forge welding this guy. Lower heat is better, but you've got to make a good stick. And the trick is your only place you're going to hammer is going to be right here in the front. You're going to leave this part back here completely alone. You don't want to touch it. This is the part that you're working with. We're about to approach a light welding heat. I'm checking this guy out, and I want to get everything set up before I actually come out with it, because you've got to get to it and get it done before it cools off. So it's in the fire, grabbing it with the tongs. Quickly I come to the anvil. Now that is a light forge weld. It is not a hard forge weld. That is not what you want. The light forge weld is to make it go ahead, stick and tack. Now the next one we do will bring the heavy forge weld. You'll actually see it throwing sparks, but what I'm going to do is reflux this whole guy and then bring it all the way back up to heat to the proper forge weld. Okay, we are ready to go with a full welding heat, and here we go. As you can see, we took the full welding heat. Everything appears to be stuck together pretty well. However, what I'm going to do is I'm going to once again flux it and take yet another full welding heat just to make sure that the job is done. Once again, we're attacking this with kid gloves. We're being very timid about it, but this will severely help out with the forge welding process with this high carbon steel. So let's flux again and go back to it. Once again, we're approaching the full welding heat. And once you see the sparks, you don't want to stop there. You do want to cut your air blast back a little bit. And like I said, you want this thing to soak. You want that heat to get all the way through it. So, caught a spark there. Let it burn my ass up. Go ahead and push this on up to heat. I meant to come right out after I turned the recording on, but you have to make do. All right, now we're ready to go. Fan goes off. Piece comes out. And you can see this guy is now fully welded up. Ba-bam, cha-ching. Now this is where you start shaping and pulling out the bulk of your axe. This is where you want to use the crossbeam hammer just to spread this guy left and right. Now if you just use a flat face, it's going to kind of spread it in all directions equally. You don't want that. You want to spread this guy up and down to make a wide front head. I've got my crossbeam hammer, and once again I've taken this guy up to a pretty high heat. I'm going to use that crossbeam now to start stretching the hammer in the directions I want it to go. I mean, the axe, excuse me. Got a hammer on the brain. Now I flip it over to take all those chop marks out that I had just put in. Okay, now there's what you've got. Now she doesn't look too grand right now, but what you're going to do is you're going to come back with the grinding wheels and really alter the shape of this. You just need enough material to get in there and work with the grinder. Now there's the other important part. Now the drift that we made was square, but what you will do later on is as you get more and more confident, you can actually make different types of drift. Now Jay used a long eye drift that's very similar to that shape right there. And I have one of those floating around here somewhere. And you don't have to have a drift, but it helps in getting that shape consistent so that, you know, the handles that you make afterwards will all fit. But for right now, what I'm going to do is I'm going to let this cool off naturally, let it anneal, and then I'm going to take it to the grinders and start doing the grind work before I finish this guy up. Now the neat thing about this is that we've used a piece of high carbon steel to make it. Now in the old days, you usually had to insert a piece of steel into here as a bit. But since we don't have to do that, it's really cut and paste. Now that we've made the forge weld, it's been folded, now we just need to grind, dress up, and then we'll dress the eye for the proper handle. But that's pretty much it. It looks rough right now, but you'll like it when it gets finished. Okay, so now we have our piece that's cooled down, and now we're going to start some shaping on the belt sander. Now, of course, you don't have to have the belt sander. You can have the angle grinder, the files, whatever you like. Once again, though, if you are going to be using files, this piece has to be completely annealed. That means you take it up to 1200 degrees Fahrenheit, which is non-magnetic, drop it in a bucket of ashes, and let it cool over the course of 3 or 4 hours. Then it will be soft enough for you to be able to work with the file. That's one of the great things about abrasives, like angle grinders, like belt sanders, is the fact that whether it's hard or not, it will still bite it, it will still scratch it. So let's do a little bit of work real quick. Show you how this goes from nasty to not so bad. All right, you can see how I'm using the wheel to get right into there. Now we have a nice smooth edge going up to there. And let's go on this side now using the big wheel. One of the things that 8-inch wheel, or that big contact wheel, is used for is applications just like this, where you need that long, gradual, smooth curve. Okay, now you see it starting to shape up. Keep it halfway cool. And now that we've got that, I'm actually going to go ahead and I am going to, oh, I got a little bit of bulge right here. I don't like that, so I'm going to even it down just a little bit. I like that look better. And now I'm actually going to rip the primary bevel. Now I'm not going to sharpen this thing, but I am going to take that edge into place. Just to give us an idea. Okay, now what you have is a pretty attractive looking little mouse hawk. Now obviously you can adjust the size of your steel or anything else you want to fit the size of the hawk that you want. This is a little hack around the shop hawk. You know, this is for detail carving and stuff like that. Now, the only thing about this guy is that the eye is still a little off. Now, this is where a drift comes in. Now, you can actually now when I say drift, you don't have to forge out a big drift. You can actually come in here with a 1-inch piece of round stock, solid or even pipe, ram it through here, and hammer this guy to fit it. But what I mean by that, let me get my thoughts together here. Put this bad boy in the fire, take a piece of 1-inch, jab it through here, hammer it to fit the piece of 1-inch, and then you have a 1-inch perfectly round hole there that will accept a 1-inch dowel rod or whatever else you want to do. Now, of course, a stronger handle is always something that's oblong like this, but it takes a lot longer to carve a piece of wood to fit in this guy than it would to grab a piece of dowel rod. Now, of course, all that you would do from here is temper the edge, and you're ready to go. You would harden and temper the edge. The big thing about this is, and I want to make something really clear to you guys, is the fact that back in the day, is that a lot of the tools they had were nothing more than wrought iron, which was much, much softer than the steels that we have today. So even if I were to leave this guy just like it is, it would be a better tool than what they used to have. So, you know what? Don't get hung up on the details. Now, if you want to do it the right way, the modern way, no problem. Harden and temper that edge, and you will have an axe that will last you a lot longer than anything you can buy in the store. But like I said, don't get hung up too much as a beginner. Now, for you maggots out there that are starting to move up into the intermediate situation, the honeymoon is over. For you guys, it is time to start flexing your wings and start doing some of these advanced techniques like the hardening and the tempering and not leaving it alone just like it is. You have down what works. It is now time to start learning what works better. And in the next videos that we'll be doing, of course, we will be walking you right up that slope. So, there it is. You fit that guy to a handle, and you're ready to go with your very own mouse hawk. Now, if you get fancy, of course, you can take this guy and clean it all the way up. But it takes out some of that nice texture that the file's left in there. And what's pretty neat, and what I do with these guys, is that I'll leave all the file texture in it. Why? Because when I go up to somebody and say, I made this out of a rasp, they say, there's no way. I say, well, look, there are the teeth. So, really neat way to start a conversation and kind of get one up on your pride. Outside of that, guys, that's going to be our video today. I hope you learned a little something, and I will see you guys next week. Take care.